One of the expectations in grade 8 is to determine the angle relationships for intersecting lines and for parallel lines and transversals. To do this, I need to add in two new screens. So I'm going to go to this tool here, pick View, and select Algebra. And then I'm going to go back and select Input Bar. Now what I want to do is draw parallel lines. So I'm going to go to my Line tool, and I'm going to draw my first line. Then I need to make a point somewhere not on that line, so I'll make my point here. Then I go to this tool here. This lets me draw perpendicular and parallel lines. I need a parallel line. It says to select a point and a parallel line, so I'll select point C and this line. I now have two parallel lines. Notice that if I move, say, point B, the other line always stays parallel to that first line. I'm now going to draw a transversal, so I'll go back to my line tool and draw a line that intersects my two parallel lines. What I want to do now is I want to measure these four angles in here and these four angles in here. To do that, I need another point on the second line or the parallel line. So I'm going to pick Point on Object and place a point there. I also need to find these 2 points of intersection, so the intersection of these two lines and then these two lines. So to do that, I go to Point and select Intersect, and then I pick this line, and there's that point of intersection, and then this line, and I have that point of intersection. Now what I want to do is measure this angle in here. It looks like BGD. So to do that in GeoGebra, you need to know that if this is the center of a clock, then we go counterclockwise to measure the angle that we want. So I'll go to my Measure tool, I'll select Angle, and I'll go BGD. And that gives me that angle there. It looks like it's about 84 degrees. I'm also going to measure this angle here. So again, I have to go counterclockwise, so I will go AGH. Your students may at this point notice that those two angles are equal, and so they may speculate that they may ask if it's always equal. So at this point, you can now move around your point B to show that while the angles change, they are always equal to each other. So vertically opposite angles are equal. I'm now going to measure these two angles in here. So I'll go back to my Measure tool, and remember that I need to go in counterclockwise order. And again we notice that these two angles are also equal. Your students at this point may notice that these two angles sum to 180 degrees, and I can show you shortly how you can verify that. I'm now going to find the measure of these four angles using the same procedure as before. And I'll just move them so that you can see the angles. So at this point, you may ask your students to hypothesize any angle relationships they may see. So they may notice that alternate angles are equal, they may notice that corresponding angles are equal, and they may also notice that these two angles, these two co-interior angles, or these two angles, sum up to 180 degrees. Let's see if we can verify that. So to verify that, I go to my input bar and I select this tool here. This lets me choose the Greek letters. So I'm going to pick these two Greek letters to see if they add up to 180 degrees. So I'm going to take this plus and then that one. And if I scroll down, you'll see that indeed the sum is 180 degrees. And if I move my points while the angles change, that sum always remains 180 degrees. Thank you.